Hi everyone, welcome to the channel. This is Fahad Mirza, and in this video I am going to share with you a new model with a new twist which I believe will be used in most of the vision models going forward, at least in the next 1 year or so. The reason why I say that is that because this new model has combined the power of large language models with the innovation of CLIP models. In this video, not only we are going to install this model locally, I will also show you some of the coding around it. But more importantly, in my opinion, we will see what exactly this LLM to clip is, what is clip, and why I am so excited about its promise. This model has been created by Microsoft, and Microsoft has really thrown it out of the park with a lot of cool stuff in generative AI in the last 1 year or so. You have to give it to them. So anyway, coming back to the topic, what exactly this LLM to clip? Before we go into this LLM to clip, let's first try to understand what is clip. And as is the spirit of the channel, I'm not going to assume that you are machine learning scientist or AI guru. We are going to keep it simple and stupid, and we are going to just speak in layman language. So what is clip model? Clip model is an AI model that helps computers understand the relationship between images and text. For example, if I see an image of an apple, I know that it's an apple. But if we have two um, components, one is the image of an apple and then text saying it is an apple, if we give it to the computer or the AI model or anything, any application, it won't know about it because it doesn't have any senses. Now, the model which establishes this relationship between an image and a text, that this image which says it's an apple is an apple, is called as CLIP model. CLIP stands for Contrastive Language Image Pre-training, and it does, or it establishes the relationship between an image and text by creating a shared space where both image and text can be represented together. This allows this clip to perform tasks like image classification, object detection, and image text retrieval. If you have been following my channel, for example, whenever I do a stable diffusion model or flux model or similar models and we generate text to images, you also see that I select something clip model. So that is the purpose of clip model in all those components. Now, what this LLM to clip is doing, it is a sort of upgraded version of clip that incorporates large language models like Llama or GPT-4 as a, and they provide advanced language understanding to this clip model. Think of it like this: clip is a skilled image text matcher, but it struggles with complex text. LLM to clip brings in a language expert, which is LLM, to help clip better understand text, making it even more powerful image text matcher. Seriously, after reading this paper and looking at this model, I was wondering why didn't anyone think of it before. Anyway, but this is how technology evolves. So now you know what clip is, LLM to clip is, and not only this is the model LLM to clip in Llama 3 8 billion version. There is also few other flavors which you can check on Hugging Face repo of Microsoft, but I'm just going to go with this LLM to clip Llama 3 8 billion instruct version, which is CC fine tuned. And there is a lot of other information around its architecture and stuff. And if you look at this diagram, this is what I have explained in simple words as how clip is working. So this cloud is LLM, it is joined with clip model, and then on the right hand side, now clip is able to understand even very esoteric, very vague concepts, and it is utilizing the power of this LLM. This is what it is happening in this image, and I will drop the link to it in video's description. Before I move forward, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. AgentQL is a query language for extracting data from web pages quickly, easily, and at scale. And you can use the Python SDK to run your queries in production using Playwright. AgentQL is a robust alternative to fragile XPath and DOM CSS selectors, as it uses the power of AI to analyze the page structure to find the data you are looking for. Okay, so enough talk. Let me take you to my terminal, and then where I'm running Ubuntu 22.04 and I have this GPU card NVIDIA RTX A6000 with 48 GB of VRAM courtesy massed compute. I'm going to create this Conda environment. Let's wait for it to get created. Let's also install LLM2 vector for embedding, which is a numerical representation. Let's wait for it to get installed. And this is installed now. Let's git clone the repo of LLM2CLIP from Microsoft, and we have seeded into it. Next, we need to install all the requirements from the root of this repo. Let me run it. It is going to take a couple of minutes. Nope. Okay, so let me see what is happening here. Maybe. Okay, so I just need to go into that directory, I believe. So if you do ls here, we need to go into LLM2CLIP because there are nested ones. So now if we run this should work now. So let's wait. And that is all done. Next, let me launch my Jupyter notebook so that we could play around with this model. It is going to open in the browser. Okay, so let's first download the model after importing these libraries. And you can see that we are going with this Llama 3 8 billion instruct one. So let me download it. So for the clip model, we are just checking with this Microsoft LLM2CLIP OpenAI model. And then for LLM, we are going with this Llama 3 8 billion, which has been specifically fine-tuned for this method. If I just scroll down, you can see that it is downloading the models. So let's wait. And after the clip model, it is downloading the LLM. And if you have seen my previous videos, you know that Llama model, the 8 billion one, has 4 shards. So it is now downloading that. And the model has been downloaded, and also it is now loaded onto our GPU. Let's try this model out. Now in this code, we are giving 3 captions, 1 image, and this is the image where I have Komodo dragon. So the captions which I'm checking is that, is this a diagram, a dragon, or a cat? Then we are opening the image. We are sending the image to the model after tokenizing it, and then we are getting the response back, and then we are printing the probabilities. Now, what I'm expecting is that these two should have low probability, whereas this should have higher probability. Let's run it. Okay, so it's very quick. So you see, I'll just go up a little, a bit more. Okay, now you see diagram has a very low probability. So anything between 0 and 1, 0 is impossible, whereas 1 is certain. Now this is a full tensor. So the shape of this tensor is that there is this 1 row and then 3 columns. Now if you look at it, you can tell that in this one, 0 has this first value is closer, way less than 0. Same goes with the last value, whereas this is 1. So it is extremely certain that this is a dragon. So this tensor is indicating that there is 1 image, 3 captions, and then the middle caption is the spot on certain one. So this is how good this model is. Okay, in this next example, I have given it 3 captions: a car, a girl, and a truck. And then I am giving it this image of a truck. So let me run it. While it runs, it's already ran, but quickly let's check how much it is VRAM it is consuming. Let me run it again. So there you go. So it is consuming around 44 gig of VRAM. So because it is also using the LLM, the full one. Okay, so it's a heavy model. Now you can check it out that now for this one, you can see that the last one, the probability is 100%, very close to 1, whereas rest of them are not really that close. So all in all, really good stuff. Model is doing awesome job here. LLM2CLIP, very excited about it. I think this is going to be huge in coming days. Also, if you're looking to rent a GPU on very affordable prices, I would like to introduce you to our good friends at Mast Compute. I will also drop the link to their website plus a coupon code of 50% discount for a range of GPUs. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps a lot. Thank you for watching.